Which one do you want to see first?
21, 21.
21 is first. All right, on number 21. Let's see, we probably ought to pay attention to the directions. For 21, the directions say find the derivative by the limit process. That means find the derivative by using the definition of derivative. All right, so the definition of derivative is that f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x, all that over delta x. All right, so first hurdle, we've got to get f of x plus delta x written in there correctly. So you go back to the function, and every time you see x, you replace it with x plus delta x. So instead of it being 1 over x minus 1, replace the x with x plus delta x. So it becomes 1 over x plus delta x minus 1. So that's f of x plus delta x minus f of x. Well, so just copy down f of x. And then your denominator is delta x. You with me on step 1?
Yeah.
All right. So now we realize, well, I can't substitute because that would give me a denominator of 0. So I need a factor of delta x in the numerator. I can't get a delta x as a factor in the numerator because the only delta x I have is right there. It's stuck in a fraction. All right, so let's get rid of the fraction. We need to multiply then the top and bottom by the least common denominator of these two fractions. It's not even that hard. 99 times out of 100, multiply by that denominator times that denominator. That'll always work. Even if it's not technically the least common denominator, that will always work. So we multiply by the quantity x plus delta x minus 1 times the quantity x minus 1. And if you multiply that times the numerator, you got to multiply it times the denominator. All right. Good so far? All right. So the first place we seem to have trouble is the very first step when you're figuring out what f of x plus delta x is supposed to look like. And then this step right here seems to be the next big issue we have. This is one thing. Think of that as A. Now I've got to distribute A times those two terms in the parentheses. So I'll multiply A times that fraction, then I'll copy down a minus sign, and then I'll multiply A times that fraction. Okay? So when I multiply A times that first fraction, so there's my first fraction, here's times A. All right? First fraction times A. You with me? Well, look. The whole reason we're multiplying by A is so that we can get rid of the denominator of that fraction so that it's not a fraction anymore. If you had 1/2 times 2 times 3, wouldn't you divide that 2 with that 2 and end up with 1 times 3? So I've got the same thing. I've got 1 over x plus delta x minus 1 times x plus delta x minus 1, divide out the factors of x plus delta x minus 1. Leaving me with, instead of 1 times 3 like I have over here, leaving me with 1 times x minus 1. And what is 1 times x minus 1? It's x minus 1. So that's what goes on the next line. Make sense? We're not finished with that step, are we? Now, we've got to multiply that second fraction. times a. So copy down the negative sign, and then the second fraction, 1 over x minus 1 times a, x plus delta x minus 1 times x minus 1. Now, this time, I'm not dividing out that factor of x plus delta x minus 1, am I? Since my denominator is a factor of x minus 1, it divides out with the other factor of x minus 1, leaving me with 1 times x plus delta x minus 1. And what is 1 times x plus delta x minus 1? X plus delta x minus 1. Do not multiply your denominator out. Leave it factored. Can you now get that far? Can you now get what I have in this black box? Questions getting to the black box. All right, we're in good shape now. Okay, the hard part's over. Now, well, don't mess it up, but you've done the hard part. Okay? All right. Now, let's keep simplifying. So here in the numerator, let's distribute that negative. So we've still got the limit as delta x approaches 0 of. So I copy down the x minus 1, distribute the negative. Make that a negative x, a negative delta x, and a positive 1. And that gets me let's see. This far. That was a lot of work just to put an arrow there, wasn't it? It's fun, though. Okay. Now, start combining like terms. I've got a positive x and a negative x. That's 0. Negative 1 and positive 1, that's 0. So the only thing left in the numerator is a negative delta x, which gets me this far. So I've got the limit as delta x approaches 0 of negative delta x over, and then it's the same denominator I've had for a couple steps. I have not multiplied it out. And now you see why I have not multiplied it out. Because I can divide out a delta x. That delta x divides with that one, leaving you with just a negative 1 as your numerator, and then x plus delta x minus 1 times x minus 1 is our denominator. Notice I'm still writing down limit as delta x approaches 0. Now I'm ready to substitute. So replace delta x with 0. Not x, it's delta x that's approaching 0. So replace delta x with 0. So your first parentheses becomes x plus 0 minus 1, so that's x minus 1. Your second parentheses remains x minus 1. So I've got negative 1 over x minus 1 times x minus 1. And what do we usually do? Instead of writing something times itself, we usually write it as that something squared. So negative 1 over x minus 1 quantity squared. Well, that was fun. Questions on 21? That is the formula for the slope of the tangent line. All right, let's do 11. Alex, question? We'll get to it. Where's 11? There it is. All right, on 11, it says find the derivative by the limit process. F of x equals 3. So the definition of derivative, which is what they mean by the limit process, is that f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x. All of that is over delta x. All right, so we got the limit as delta x approaches 0. Oh, where'd my arrow go? Oh, it went away. How sad. So I have to do this. See, I can't make an arrow. Maybe if I do that. There's an arrow. All right, so we got the limit as delta x approaches 0 of f of x plus delta x. You go look at f, and every place that you see an x, you put an x plus delta x. How many places do you see an x? None. So how many x plus delta x's do you put in there? None. So f of x plus delta x is 3 minus then f of x. What's f of x equal? 3 over delta x. What's 3 minus 3? 0. So this becomes 0 because 0 divided by any other number equals 0. Now you might say, but wait. Delta x is also 0. No, it's not. What's delta x? It's approaching 0. It's not equal to 0. So 0 divided by any other number is 0. So now it's just the limit of a constant. And the limit of a constant is always itself. Cha-ching. All right, 11 makes sense to you now? 29. All right, on 29. This time the directions say, find an equation of the tangent line to the graph of f at the given point. That's what we'll do here, then we'll let the calculator does the rest. So, not only do we need to find the derivative, we need to use the derivative to get the slope of the tangent line, and then we use that slope to get the equation of the tangent line. And that's the order it's got to go in. Derivative leads you to the slope, leads you to the equation. Okay? So f of x equals the square root of x, and the point of tangency is 1, 1. By now, you should be getting familiar with that step. Okay? And once you've got the definition of derivative down, you don't have to write it every time, but you better have it down. Well, even more than knowing it, keep writing that down until you can do the substitution step perfectly, okay? Because it's more than just memorizing the definition. You've got to be able to put the x plus delta x in and get the correct f of x plus delta x. I think until you get really, really good at that, it's going to help to be looking at the definition while you do so. So there's our definition. Now, limit as delta x approaches 0 of f of x plus delta x. So you go to f of x, and every time you see an x, you put in an x plus delta x. So that'd be the square root of, you see an x, so put in x plus delta x. So that's f of x plus delta x. Okay? Copy down the minus sign, and then you put f of x. Well, f of x equals the square root of x. So it's the square root of x. Your denominator, as always, is delta x. So that's the first tough part. Using the definition of derivative correctly to get the proper f of x plus delta x. We good? All right. Now we got to use our limit techniques. Well, let's see then. I've got a binomial. At least one of the terms in the binomial has a square root in it. So quite often what we did back in chapter 1 was multiply by the conjugate of that binomial. So the conjugate will be the square root of x plus delta x plus the square root of x. As you know, If you multiply the numerator by that, you've got to multiply the denominator by the same thing. Now, I think this is a little easier to simplify than the one we did on 21. Because what I see when I look at this is I see A minus B times A plus B. And I know that the result of that is A squared minus B squared. So if A is the square root of x plus delta x, A squared would be the square root squared, so you get x plus delta x. Then it's minus, so minus, then it's B squared. Well, if B is the square root of x, the square root of x squared is x. So that situation needs to become fairly simple. Okay? Now, easy and simple aren't always the same thing. Simple meaning you should know what to do. It may not be all that easy to do it, but you should know what to do. All right? And do not multiply the denominators together. Leave it factored. Everybody here with me? All right. We should be in pretty good shape getting the rest of the derivative now. So I've got x plus delta x minus x. Well, I know what x minus x is. It's 0. So the only thing I have left in the numerator is delta x. So I'm still writing down limit as delta x approaches 0. And I have not changed my denominator. I still have not multiplied it out. And why did we do all this multiplying anyway? So that we would have a factor of delta x in the numerator to divide out with that factor of delta x in the denominator, getting me here. Can we substitute now? We can substitute now. Because it won't give us a denominator of 0 now, because the factor of delta x that was going to make the denominator equal 0 is not there. So replace delta x with 0. So 1 stays 1. Replace delta x with 0. So I'll get just the square root of x. That's going to stay square root of x. All right? Now, the square root of x plus the square root of x is not the square root of x squared. It's 2 times the square root of x. So this is our derivative. The derivative is a formula to find the slope of the tangent line. So now that we have the derivative, we use it as a formula to find the slope of the tangent line. Why are we doing that for this problem when we didn't for the others? Because the directions for this problem say for us to. Okay? So, at the point 1, 1, where did I get the point 1, 1 from? They gave it to me. It's in the problem. F prime of 1. Now, if f of 1 means the value of f when x equals 1, f prime of 1 means the value of the derivative when x equals 1. So at the point 1, 1, f prime of 1 equals, and then use your formula. Replace x with 1. So 1 over 2 times the square root of 1. Square root of 1 is almost always 1. I don't want to go out on a limb and say it's always 1. Pretty sure it's almost always 1. So I get 1/2. What does that mean? That means the slope of the tangent line at the point they gave us is 1/2. Does that mean the slope of the tangent line for every single point on this graph is 1/2? No, just this one. Now that we know the slope of the tangent line and we know a point on our line, we know a point, we know the slope, use point slope. Y minus y1 equals m times x minus x1. So y minus 1 equals 1/2 times x minus 1. And unless you're told, well, always just count on putting it in y equals mx plus b form. Everybody considers that the most useful form. Now, when the AP test rolls around, we'll amend that because the AP people, unless they tell you to put it in that form, they don't care. For them, you could stop there unless they tell you to put it in a specific form, okay? But they're the only people that don't care. Everybody at your college teacher, they're going to probably want you to put it in that form, okay? All right, can you do the calculator stuff? All right. Let's do one more. 17. All right, on 17, we got a good old polynomial. And what are we doing? We're finding the derivative using the definition of derivative. So f of x equals 2x squared plus x minus 1. We know the definition by now. F prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x, all that over delta x. All right, so we have the limit as delta x approaches 0 of f of x plus delta x. So go to your function f. Every time you see x, replace it with x plus delta x. So instead of 2x squared, it's 2x plus delta x squared. Instead of plus x, it's plus x plus delta x. Instead of minus, oh, it stays minus 1, doesn't it? All right. You good with f of x plus delta x? Minus, so minus, parentheses, f of x. So just put f of x in there. Put in 2x squared plus x minus 1. And our denominator stays delta x. We good on that step? All right. Now, let's do some algebra. So, we've got the limit as delta x approaches 0 of, and again, like we talked about yesterday, you got to do all the steps. Some of them you want to do in your head just because you're as likely to copy things down wrong as you are doing the other mistake. So, when I square a plus b, I get a squared plus 2ab plus b squared. So when I square, and I'm thinking all this in my head when I'm working this, when I square x plus delta x, I get x squared plus 2x delta x plus delta x squared. I know that's what I'm going to get. Well, I also got to distribute the 2, don't I? So mentally, I've squared that binomial, and then I distribute the 2. So 2 times x squared, 2x squared. 2 times 2x delta x, 4x delta x. 2 times delta x squared, 2 delta x squared. All right? Then copy down the rest. Plus x plus delta x minus 1, and you can't hardly see it, but here I'm distributing that negative, making that a negative 2, a negative x, and a positive 1. And it didn't show up well, but that's what I did. Okay? So you good on that step? Because if you get that step, I think you're in good shape. All right. So what do we got? Well, we've got a positive 2x squared and a negative 2x squared. That's 0. What else do we have? We have a negative 1 here and a positive 1 there that didn't show up. That's a 0. We've got a positive x here and a negative x here. That's a 0. So I'm left with 4x delta x plus 2 delta x squared plus delta x. And I still have just delta x as my denominator. All right, I'm in good shape now. Take out a factor of delta x in your numerator. And by the way, I keep not saying it, but you got to keep writing limit as delta x approaches 0. All right, so factor out a delta x. When I take out a delta x from 4x delta x, I get 4x. When I divide a delta x out of 2 delta x squared, I get 2 delta x. When I divide delta x by delta x, I get 1. And now, the delta x I factored divides out with the delta x in the denominator. Got the limit as delta x approaches 0 of 4x plus 2 delta x plus 1. Substitute. Replace delta x with 0. So 4x plus 0 plus 1 is 4x plus 1. If they wanted us to, we can now use this to find the slope of the tangent line at any point on this graph. Just pick an x-coordinate, and then that's your formula to find the slope of the tangent line for that x-coordinate. Questions? Seem a little better now than it did last night? Hey, these were hard to do on your own. I know that. Okay? So what I want you to do for your homework over the weekend is to finish, if you didn't finish, redo if you need to redo, and if you finished and you did them all perfectly well, then I would gloat to all my classmates.